My dear students, welcome back to our channel. In this video, I will be explaining the BCom first semester subject FIT Fundamentals of Information Technology as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define digital transformation in business. Digital transformation in business means using modern digital technologies to change the way a company operates, serves customers, and grows. It is not just about using computers or software, it is about improving processes, making smarter decisions, and creating better experiences for customers. For example, a small retail shop can transform digitally by introducing an online store, using digital payment methods, and managing inventory through software. This makes shopping faster for customers and helps the shop owner track sales easily. Digital transformation can include using technologies like cloud computing, mobile apps, AI, IoT, or online marketing tools. It helps businesses become more efficient, reduce costs, compete better in the market, and reach more customers. In simple words, digital transformation is equal to using technology to work smarter, serve customers better, and grow business faster. Next important short question is: to list the main components of a computer system. List the main components of a computer system. A computer system has two main parts, hardware and software. 1. Hardware. These are the physical parts you can touch. CPU, Central Processing Unit, the brain of the computer that processes instructions. Memory, RAM and ROM. RAM stores temporary data while the computer is running, ROM stores permanent instructions. Input devices, tools used to enter data, like keyboard, mouse, or biometric devices, fingerprint scanner. Output devices, tools that show results, like monitors, printers, or IoT-enabled displays. Storage devices, hard drives or SSDs where data is saved permanently. 2. Software, these are programs that tell the hardware what to do. System software helps run the computer, example, Windows, Linux. Application software helps perform tasks, example, Excel, WhatsApp. Example, a shop uses a computer with a monitor, keyboard, POS software, and printer to manage sales. Next important short question is: 3. Give 4 differences between RAM and ROM. Differences between RAM and ROM. Feature: RAM, random access memory, ROM, read-only memory. Type of memory: volatile, data is lost when power is off. Non-volatile, data remains even when power is off. Purpose: stores data and programs temporarily while computer is running, stores permanent instructions needed to start the computer. Writable: can be read and written multiple times, mostly cannot be changed, pre-installed by manufacturer. Speed: faster memory for quick access, slower compared to RAM, mainly for booting tasks. Example, when you open a game on your computer, it loads into RAM for fast play. The computer's startup instructions are stored in ROM, so it knows how to boot. Simple way to remember: RAM is equal to temporary working desk, ROM is equal to permanent instruction book. Next important short question is: 4. Software, system and application. Software, system and application. Software is a set of programs or instructions that tell the computer how to work. Without software, hardware is useless. There are two main types of software. 1. System software. Helps the computer run smoothly and manage hardware. Example, operating systems like Windows, Linux, or Android. It acts as a bridge between hardware and application software. 2. Application software helps users perform specific tasks. Example, Microsoft Word for typing documents, Excel for calculations, WhatsApp for messaging, or a POS app in shops. Example, in a shop, the computer uses Windows, system software to run and billing software, application software to manage sales and print receipts. Simple way to remember, system software is equal to engine of a car, application software is equal to tools to drive it. Next important short question is 5. Name 4 modern input-output devices. Include 1 biometric or IoT device. Modern input-output devices. Input devices are used to enter data into a computer, and output devices are used to show results. Modern devices include biometric and IoT tools. Examples. 1. Fingerprint scanner. Biometric input reads fingerprints to allow secure login. 2. Smart card reader. IoT input reads cards for payments or identification. 3. Touchscreen monitor. Input and output lets users interact directly with the screen and also shows results. 4. 3D printer. Output creates physical objects from digital designs. Example, in business, a retail store uses a fingerprint scanner for staff login, a POS touchscreen for billing, and a 3D printer to produce customized products. Simple way to remember, modern devices is equal to smart tools that let computers talk to humans and humans talk to computers, safely and efficiently. Next, Unit 1. Long questions. First important long question is: explain the strategic role of IT into functional areas of a business. Choose from finance, marketing, HR, SCM, with examples. Strategic role of IT into functional areas of a business. Information technology, IT, plays a key strategic role in modern businesses by improving efficiency, decision-making, and customer satisfaction. Let's look at finance and human resources, HR, as examples. 1. Finance. IT helps finance teams manage money, track transactions, and make accurate financial decisions. For example, businesses use accounting software like Tally or QuickBooks to maintain records, generate reports, and manage budgets automatically. Banks and companies also use IoT-enabled smart ATMs that allow secure and fast cash withdrawals, reducing human errors and increasing customer convenience. Using IT in finance helps businesses detect fraud, forecast cash flow, and make smarter investment decisions. 2. Human resources, HR. IT improves HR operations like recruitment, payroll, attendance, and performance management. For example, companies use biometric devices such as fingerprint scanners to record employee attendance accurately. HR software like Joho People or SAP SuccessFactors helps track leaves, manage appraisals, and organize training programs efficiently. This reduces paperwork, avoids errors, and saves time, allowing HR managers to focus on employee engagement and development. Why IT is strategic? Efficiency automates repetitive tasks and reduces human errors. Decision-making provides real-time data for faster, smarter choices. Customer and employee satisfaction enhances service quality and internal management. Competitive advantage: companies using IT strategically can respond faster to market changes. Example, in business, a retail company uses a biometric attendance system for staff, HR, and an IoT-based payment system for customers, finance. This ensures smooth operations, secure transactions, and satisfied employees and customers. Simple way to remember: finance is equal to smart money management with IT, HR is equal to smart people management with IT. Next important long question is: 2. Draw and explain the block diagram, logical organization, of a computer system and describe the function of each block. Block diagram and logical organization of a computer system. A computer system is made of several blocks that work together to process data and provide output. The main blocks are: 1. Input unit. Takes data from the user and converts it into a format that the computer can understand. Examples: keyboard, mouse, scanner, or a biometric fingerprint scanner. 2. Central processing unit, CPU, the brain of the computer, which processes all instructions. It has 3 subblocks. Arithmetic logic unit, ALU, performs all calculations, addition, subtraction, and logical operations like comparisons. Control unit, CU, directs all operations inside the computer, telling other units what to do and when. Registers, small, high-speed storage areas for temporary data during processing. 3. Memory unit. Stores data and instructions needed for processing. RAM, random access memory, temporary memory for active tasks. ROM, read-only memory, permanent memory that stores basic startup instructions. 4. Output unit. Converts processed data into a human understandable form. Examples: monitor, printer, or IoT-enabled display boards. 5. Storage unit. Holds data permanently for future use. Examples: hard disk drives, HDDs, solid-state drives, SSDs, or cloud storage. Example: in business, in a retail store, a POS system uses a keyboard or touchscreen input unit to enter sales data. The CPU processes the information, RAM temporarily holds active transactions, and the receipt printer, output unit, gives the customer a bill. All records are saved in the storage unit for future reference. Simple way to remember: input, process, store, output is equal to computer's way of thinking and working. Next important long question is: 3. Explain bits, bytes and basic data representation, binary numbers, ASCII Unicode concepts, and why they matter for storage communication. Bits, bytes, and basic data representation. Computers understand only digital data, which is represented in binary form, zeros and ones. The smallest unit of data is a bit. Bit, a single 0 or 1. Byte, a group of 8 bits, enough to represent a character like A or 5. Why binary is used? Computers use electronic circuits that can be either on, 1, or off, 0. Binary makes it simple to store, process, and transmit data reliably. Data representation. 1. ASCII, American Standard Code for Information Interchange. Represents characters, letters, numbers, symbols using 7 or 8 bits. Example: A is equal to 65 in ASCII. 2. Unicode. A universal standard that represents characters from almost all languages using more bits, 16-bit or more. Example: Hindi letter is equal to U plus 0905 in Unicode. Importance for storage and communication. Storage. Computers store all files, text, images, videos as bits and bytes. Knowing the size in bytes helps understand memory requirements. Communication. Data is transmitted in binary over networks. Using standards like ASCII and Unicode ensures that messages appear correctly on all devices. Example: in business, a retail shop storing customer names in a billing system uses bytes to represent each letter. Sending invoices by email requires data to be encoded properly, so Unicode ensures names in Hindi or English are readable. Simple way to remember: bit is equal to tiny dot of data, byte is equal to 1 character, ASCII Unicode is equal to Universal Language of Computers. Next important long question is 4. Discuss ethical and social aspects of IT, digital privacy, mention GDPR and India's DPDPA, digital divide and intellectual property issues. Ethical and social aspects of IT. Information technology, IT, has transformed our lives, but it also raises ethical and social concerns that businesses and individuals must consider. The main areas are digital privacy, digital divide, and intellectual property, IP. 1. Digital privacy. Digital privacy means protecting personal and sensitive data from misuse. Laws like GDPR, General Data Protection Regulation, in Europe and India's DPDPA, Data Protection and Privacy Act, ensure that companies collect and use data responsibly. Example, e-commerce sites must get your consent before storing your payment details or personal info. 2. Digital divide. Not everyone has equal access to technology, creating a digital gap between people who can use IT and those who cannot. Example, urban areas may have fast internet and smart devices, while rural areas may lack computers or connectivity. This can affect education, business, and employment opportunities. 3. Intellectual property, IP, issues. IT makes copying and sharing software, music, videos, and designs easy. Protecting copyrights, patents, and trademarks ensures creators are rewarded and innovation continues. Example, using pirated software in a company is illegal and unethical. Buying licensed software respects IP rights. Why it matters? Ethical IT use builds trust with customers and employees. Laws like GDPR and DPDPA prevent misuse of data. Reducing the digital divide promotes inclusive growth. Protecting IP encourages innovation and fair competition. Simple way to remember: digital privacy is equal to protect data, digital divide is equal to equal access, intellectual property is equal to respect creations. Example, in business, a company collects customer data for marketing but ensures consent, uses licensed software, and provides online services accessible to urban and rural customers. Next important long question is 5. Give an overview of emerging technologies, AI, ML, IoT, blockchain, RPA, and explain one business use case for each. Overview of emerging technologies and business use cases. Modern businesses are rapidly adopting emerging technologies to improve efficiency, reduce costs, and serve customers better. The key technologies include AI, ML, IoT, blockchain, and RPA. 1. AI, ML, Artificial Intelligence Machine Learning. AI enables machines to think and learn like humans. ML helps computers learn from data and make predictions. Business use case: e-commerce websites use AI ML to recommend products to customers based on their past purchases and browsing history, increasing sales and customer satisfaction. 2. IoT, Internet of Things. IoT connects devices to the Internet, allowing them to collect and share data. Business use case: smart fridges in retail stores monitor stock levels and automatically place orders when items run low, reducing human effort and avoiding stockouts. 3. Blockchain. Blockchain is a secure digital ledger that records transactions in a way that cannot be altered. Business use case: banks and financial companies use blockchain for secure and transparent transactions, reducing fraud and improving trust between parties. 4. RPA, Robotic Process Automation. RPA uses software robots to automate repetitive and rule-based tasks. Business use case: companies use RPA to automate invoice processing or payroll management, saving time and minimizing errors. Why these technologies matter? Efficiency: automate tasks and reduce human errors. Cost savings: reduce manual labor and operational costs. Better decisions: use real-time data and AI insights for smarter decisions. Customer satisfaction: deliver faster, personalized services. Simple way to remember: AI ML is equal to smart decisions, IoT is equal to connected devices, blockchain is equal to secure transactions, RPA is equal to robots for routine tasks. Example: in business, a retail chain uses AI for personalized offers, IoT for stock monitoring, blockchain for secure online payments, and RPA to automate billing, creating a highly efficient and modern store.